Assalamualaikum everyone. We are from Group 15. Our project title is measuring the noise level of different public transport at different time. Some waves are pattern of disruption created by energy flow when sound travel through a medium, allowing us to talk and hear music. The human ear is sensitive to audible wave with frequency ranging from 20 Hz to 20 kHz. Noise, a phenomenon from this wave, can be created in both the time and frequency domain. The project aims to measure and identify noise level for each mode of public transport, including MRT, KTM, ETS, LRT, and bus. This project uses Audacity software and MATLAB software to analyze environmental noise from public vehicles, focusing on noise level in different modes of public transport.
According to a review of recent research into causes and control of noise during high-speed train movement published in 2022 stated that as the speed of the train increases, the external aerodynamic noise of the train will increase in the ratio of 6 to 8 times the speed of the train. In another study published on 2018 by Agatha Mucha, the noise level of public bus transport is found to be in the middle between tram and car, with average noise about 65 decibels and above. The guidelines for noise leveling and emission limits by the Department of Environment Malaysia stated that the permissible noise level for activities related to traffic noise such as rail, train and bus transports is basically should not higher than 80 decibels. Review on traffic noise problem in Malaysia published in 2019 measured the average daytime noise level during normal traffic on working day in several places and found that Kuala Lumpur recorded the highest mean noise, which is up to 73.6 decibels.
At the start of the project, 5 types of public transportation were selected, which are KTM commuter, MRT, LRT, bus, and ETS. All 5 types of public transportation were then assigned to each group member for the recording process. The 2 variables selected for this project is the types of public transportation and the time when the noise is recorded. For the next step, the noise sounds were recorded using microphone and smartphone. Start by connect the microphone to the smartphone, then the noise in the assigned public transportation is recorded both at the morning and in the evening. After all the audio samples were obtained, the audio files were transferred into the Audacity software. In this project, we also use MATLAB to run a series of code to analyze the audio signals and data from the noise audio files. The MATLAB is used to plot the oscillogram, graphs, and other statistics and parameters. Lastly, all the data will be tabulated to make it easier to be observed and analyzed. The graphs and other significant parameters from all the 5 different public transportation will then be compiled together for comparison to be made and further analyzed.
The next part is the MATLAB coding that we did using the MATLAB software. So basically the first step is reading file and introducing variables. Here is the coding for the file path, which is assigned to the variable audio file, which will then be replaced with the actual path to our audio file. The next code is related to computing and plotting the frequency domain spectrum of a signal. So basically after we execute the code as shown, we should see a plot showing the spectrum of the signal with frequency on the x-axis and magnitude in decibels on the y-axis. The Blackman windowing helps reduce the spectral leakage effects. The next code is related to computing and plotting the time domain waveform. After we execute the code, we should see a plot showing the time domain waveform of the signal with time on the x-axis and the amplitude on the y-axis. The plot will also have grid lines, axis labels, and a title. After we execute this last part of the code, we will see the displayed values of the maximum, minimum, mean, RMS, and dynamic range of the signal in the MATLAB command window. These statistical measures provide insights into the characteristics and properties of the signal. The next part is the results that we obtain from the coding that we compute using the MATLAB software. From the coding, we will obtain a time domain waveform and a frequency domain spectrum. We will also get the statistical measures such as the value of the maximum, minimum, mean, RMS, and dynamic range from the audio file that we used. Since we are investigating the audio signals from 5 different transports, Here are the results for each type of transport. Based on the result from all transports, we can conclude the MRT bus has the highest maximum amplitude during the morning and evening compared to other transports, while KTM has the lowest minimum amplitude during the morning and evening.
It is known that the noise level in different types of public transport, namely MRT, KTM, LRT, public bus, and ETS, were studied. They were recorded during two different times of the day, which is morning and evening. The maximum and minimum amplitude were important parameters in studying the loudness of the noise emitted. Based on the data obtained, the MRT emitted the loudest noise in the morning and emitted the least noise at evening. The highest level of noise inside an ETS were observed in the morning, while the lowest noise inside an ETS were observed during the evening. Next, the noise level inside the MRT bus is highest during the morning and lowest during the evening. The noise level inside a KTM commuter train is the highest during evening and lowest during morning. Last but not least, the noise level inside an LRT train is the highest in the morning and lowest in the evening.
In conclusion, morning is the busiest period for MRT, ETS, bus and LRT, followed by evening, while the busiest time for KTM is in the morning. The project used Audacity and MATLAB to capture, analyze and visually depict sound signal, aiming to reduce noise while providing comfort. Thank you.